Good day. So we'll be discussing dimensional analysis. So dimensional analysis is a simple technique wherein we relate values in a certain unit to another value of another unit. So this will be a manipulation of units. So this is also known as factor label method. Okay. So for example, I'll have here a conversion factor wherein 1 inch is equal to 2.54 centimeter. So this 1 inch, okay, 1 inch over 2.54 centimeter is equivalent also to 2.54 centimeter over 1 inch, because these values express are corresponds to the same length. So they have the same length. So there would be no problem if 1 inch is in the numerator or in the denominator. However, we tend to assign them into numerator and denominator depending on what unit is already given and what unit we would like to find. So for example, I will be having 3 inches and I would like to convert it to centimeter. So this will be 3 inch and multiply by the conversion factor. So we will be having this conversion factor. So I would like to choose which position would inch will be assigned. So in this case, since inch is on the top part, it would be better if the inch unit for the conversion factor will be assigned on the denominator. Okay, so again, this is 1 inch, this is 2.54 centimeter. Okay, so with this, we could cancel out inch at the top part and the inch on the bottom part. So this will be equal to 3 times 2.54. This will be equal to 7.62 centimeter. Okay, so next one, 7 centimeter to inch. So this will be 7 centimeter, and I would like to find the value if the unit is in inches. So since centimeter is on the top part, we would like to place centimeter on the bottom part and inch on the upper part. So 1 inch and 2.54 centimeter. So this will be equal to 2.76 inches. Okay, so we'd like to cancel this out. Okay, so the remaining unit is only inches. So let's have another example, but by this time we would like to convert cm to feet. However, our conversion factor does not show a direct conversion from feet to centimeter or centimeter to feet. So we would like them to meet to a unit wherein there will be a similarity among the two. So for this case, for cm, it would be inch, and after you convert cm to inch, you can convert inch to feet. Okay, so let's try from 150 cm multiply by, I would like to assign cm at the bottom and inch at the top part. So 1 inch to 2.54 centimeter. So the remaining unit will be inch. Now this inch could be further multiplied to the conversion factor, which is inch at the bottom. So we could cancel inch at the top part of the preceding conversion factor, inch and feet. So for every 1 feet, there is 12 inch. Okay, so cancel the units, cm and cm, inch and inch. We will be having 4.92 feet. So let's try another example. 8 feet. So no direct conversion from feet to cm, but we can convert first feet to inch, then inch to cm. So feet multiplied by 1 feet, 1 foot to 12 inches times in 1 inch. We'd like to place them in the denominator because we have the numerator inch, and cm. So 2.54 cm, then 1 inch. So we will be having 244 cm. Okay, so this is our answer. So another example is if we having metric system, and in metric system we all know that this could be assigned for unit of length, such as for mass, which correspond to the length. It could be grams as a unit of mass in a metric system, and or liter for volume. Okay, typically the prefixes such as deci or milli or centi or kilo, so they correspond to the certain exponent of tenth. So maybe I would like to, for example, this could be meter, and this is applicable also for grams and liters. So meter. So after meter is decimeter, centimeter, and millimeter. After meter, to the right is decameter, hectometer, and kilometer. Okay, so for meter, if it is 1, then decimeter should be 10, 100, and 1000. If 1 meter is 1, then decameter is 0.1, hectometer is 0.01, and kilometer is 0.001. So for this, we would like to convert meter to decimeter. So this will be 22.6 meter times meter will be placed at the bottom. The conversion factor for decimeter will be at the top. So this will be 10 decimeter to 1 meter. So this will be 226. Cancel the units. The remaining units is decimeter. 226 decimeter. So another one, milligram to kilogram. So I will just need to have this one. So apparently we could just change this meter to gram. So this will be milligram, centigram, decigram, gram, decagram, hectogram, and kilogram. Okay, so this will be a unit of mass. So this will be 25.4 milligram times in one. We have 1000 milligram, and a kilogram is 0.001. So this will be 25.4 times 0.001 divided by 1000. The answer will be 2.54. I'm sorry, I forgot the kilogram unit. Times 10 raised to negative 5. So this will cancel. The remaining units is kilogram. So 2.54 times 10 raised to negative 5 kilogram. Okay? So it is important to express this in scientific notation if the number of decimal places become really difficult to read or out of hand. So next one, kilogram to meter cube to gram cubic centimeter. So I'll be having again this number line, the number line earlier. Okay, so 10.6 kilogram over meter cube. So we would like to express it to gram to centigram. So this should be on the case wherein our final answer must have a unit wherein the numerator is gram and the denominator is cubic centimeter. Okay? So we should find cubic centimeter denominator at some point of our solution, and gram at the top part at some point of our solution. So first, let's convert kilogram to gram. So kilogram will be 0.01001 kilogram, and every 0.001 kilogram is 1 gram. Okay, so we could cancel this out, so the remaining unit will be gram and cubic meter. Now we should change meter to centimeter. So a meter should be placed at the top, so we could cancel them, and the centimeter should be at the bottom. So our final answer will be having a centimeter unit at the denominator part. Okay, so in 1 meter, there is 100 centimeter. However, you should notice that this is cubic, so we should raise this conversion factor to 3 also. So we could transform this one to cubic centimeter, wherein we will be having 1 cubic meter equal to 100 raised to cube, and cm will be also raised to cube. So 100 cubic centimeter. Okay, so cancel the similar units, will be meter cube and meter cube of this button. The remaining units will be gram and cubic centimeter. So this will be So this will be 0.0106 grams per cubic centimeter. So I would like to rewrite this one in a manner wherein I could read this one easier. So gram per cubic centimeter. Next, how many minutes does it take light from the sun to reach the earth? So we'll be having a word problem. So we would like to express this distance to a unit of time wherein the light should reach the sun to the planet earth. So the only relationship wherein distance is related to time is when they are used in speed, in determining the speed. So we have this speed is equal to distance over time. Okay, so as you can see, this is a distance, a unit of length, and time. Okay, so let's try to solve. So we are given that the distance of earth to the sun is 93 million, and the unit of length is miles. So we should relate it with the time. So we should use in order to find the time, you should use the speed and the light and the object that travels from sun to the earth. So it was pertained as light. Okay, so we should know what will be the speed of light, and it was already given on the problem. So the speed of light is 3 times 10 raised to 8 meter per seconds. Okay, so however the unit is on meter, so we should convert miles to metric. So we have a given unit which is mile conversion factor, which is mile to kilometer. So I would like to place here kilometer. So this will be 1.61 kilometer. At the bottom will be mile, 1 mile. Okay, so we could cancel these miles out. Okay, so kilometer, this is meter, so we should convert kilometer to meter. So 1 kilometer is 1,000 meter. Okay, I'm sorry, so I think I should use the other one to be uniform with our given. So point 0, this is 1 meter and 0.001 kilometer. Okay, however, if you try the earlier factor, so there's nothing wrong with it. Okay, so meter, so I would like to convert it to time. So I will be having meter as the answer at this part. Okay, so we'd like to use time. So in every 1 second, the light travels 3.00 times 10 raised to 8 meters. Okay, so we will be canceling out meters here. So the time will be on seconds. However, we would like that unit of time in minutes. So 1 minute is actually equal to 60 seconds. Okay, so cancel the similar units. Now we will be having minutes as a final answer. So let's try to solve. So our answer will be 499 minutes. Okay, so this will the time it takes for the light to travel the sun to earth. Okay, so let's have another example. How about 50 ml mass of the 50 ml ethanol? So this is a unit of volume. Okay, so the only way wherein you can relate volume to mass is when you use density. So the density is an intensive property which is only exclusive for these values. This is only exclusive for ethanol. So if you have other substance, you will be having different value for density. So what does this density means? Meaning to say, if you have 1 ml of ethanol, you will be having the mass of 0.798 grams. So, for example, if you try to pipette out 1 ml of ethanol and you weigh this 1 ml of ethanol, the mass of it will be 0.798 grams. Okay? So let's try to solve. So this is 50 ml ethanol. So we should multiply it with the density. So this is ml, so I would like to place ml here and the mass to be on the top part. So this is 0.798, and for every 0.798 grams there will be 1 ml of ethanol. So this will be 39.9 grams. So again, cancel the units. So 39.9 grams. Okay, so last example, I will be having light years. Okay, so light years. So what does light years mean? So it means that the number of years, okay, number of years the light should will take it to travel. So this may look like a unit of time, but apparently it is used for determining the distance or the length. Okay, apparently this is typically used for large scale lengths. So we also tend to use time for determining the distance. For example, you would like to travel from your house to home, and sometimes you were asked how far the mall is and how far is mall from your house. You typically you sometimes answer in a unit of time. Sometimes you answer, it is just 20 minutes away. Okay, so 20 minutes away is a unit of time, but apparently based on the context, it was used to describe the distance of mall from your house. Okay, so this is same with the light years. Okay, so we could take this one as 1.42 years. Okay, and we would like to convert miles to call this um, years, light years to miles. Okay, so this is 1.42 years. So to be more appropriate, so express this one to distance, since this pertains to the years that the light needed to travel, which we only have the chance to relate time with the distance when we describe this time as a unit for speed. So we should have a speed of light. Okay, so the speed of light is 3 times 10 raised to 8 meter per second. So this is in the unit of seconds. So before we convert it to an more appropriate distance unit, we should convert first years to seconds. So this will be, years will be multiplied by 1 year is equal to 365.25 days. Okay, times in 365.25 days, and every day you have 24 hours. Okay, in every hour you have 60 minutes, and every minute you have 60 seconds. Okay, now we have 60 seconds here, so multiply by the speed of light. So this will be second here, so I would like to place second here. 1 second, 3 times 10 raised to 8 meters. Okay, so I have here meters, so I would like it to convert to mile, and mile is 2 kilometers, so I should first convert meter to kilometers. So this will be 1 meter is 0.001 kilometer, and 1 kilometer is 1.61 kilometer is to 1 mile. So perform calculation. So use your calculator to find the value. So 1.42 times 365.25 over 1 times 24 over 1 times 60 over 1 times 60 over 1 again times 3 3 times 10 raised to 8 meters over 1 second, then times 0.001 over 1 times 1 mile to 1.61 kilometer. So the answer will be 8.35 times 10 raised to 12 miles. So this is really a very long distance. Okay, and it makes sense because the speed of light is really high, so very high speed, and the light could travel this distance in just a matter of 1.42 years. Okay, so this is how we do dimensional analysis.